So before we get into that new stuff, remember 5 times 5. How could I write this as an exponent? 5 squared. Right? And if you think about what we did yesterday, you can recognize that it's 5 to the 1 times 5 to the 1, and 1 plus 1 is 2, and that's where we get the exponent from. But we also just know that 5 squared is 5 times 5, so 5 times 5 also means 5 squared, like you can go both directions. Okay, so that's having a good understanding of just exponents. What about 3 times 3 squared? How could I write this in long form? 3 times, what's 3 squared?
6.
No. It's 9, but I don't want to write it as a 9. I want to write it in like expanded form, which is not really something we've talked about. So if you don't know what I mean, that's okay. 3 squared means, yeah, 3 times 3. So I've got 3 times 3 squared, which is 3 times 3 times 3. Well, what's 3 times 3 times 3? 3 to the 3 cubed, yes. So 3 times 3 times 3 is 3 to the exponent of 3, which is a bit confusing because there's too many 3's now. But, right? 3 3's in total. 1 came from here, 2 came from here, hence the 3. That's why we add the exponents. So again, this is just a review of what we did yesterday. That's all this is. Can you put 27? Absolutely. That's not the point of this. We're just exploring the concept. But the answer to it, if you were to evaluate it, yeah, is 27. Absolutely, yeah. And you could use your calculator to get that. Or if you know your times tables and you can do that in your head, that's fantastic. But right now, we're just looking at that idea of adding exponents. You know what I mean? Yeah. Okay, so again, review of what we did yesterday. A times A, how can I simplify?
A squared.
A squared. Again, 1 plus 1. Could you put a 1 beside it? Like that? It's not wrong. You don't have to. If that helps your thinking of what the coefficient is, yes, that's fine to do that. But as you get more comfortable and as you progress through, later grades or whatever, eventually you probably get used to the fact that you don't need to write it. There is a 1 there if you just put nothing, but it's totally fine to do it if you want to. Yep. Okay, y times y squared. Y to the 3, because it's 1 plus 2 is 3. Again, this is like y times y times y. 1y times 2 y's, so 3 y's total. And then when we add in coefficients, how do we do this one?
You do 6 times 2, and then...
Which is 12?
Yeah, and then you do they have 1 exponent each, so it's 12 cubed. I mean squares.
Squared, x squared, good. 12x squared. Don't forget the x, the squared. Why does this get so confusing especially when you add in the coefficients? Because you're multiplying the coefficients. It's 6 times 2. But it's not 1 times 1. It's 1 plus 1. So sometimes you're adding, sometimes you're multiplying, and you start to just muddle those up in your head. Even though if you really stop and think about it, you understand this and you know the difference between them. But it's still easy to make that mistake. So once again, I only bring that up because it's important to be mindful of common mistakes. What's another common mistake with these things? What's a plus a?
A
2 what? 2a. Is it squared or not squared? Not squared. And this is, once again, notice the difference. A times a is a squared. A plus a is 2a, not 2a squared. You're not multiplying the a's. So you don't change the exponent. They're like terms. It's apples. I've got one apple, then I've got a second apple. I've got 2 apples and 3 apples. How many apples do I have? 5. 1 apple and 1 apple is 2 apples. What's 1 apple times 1 apple? Well, nothing. That doesn't really make any sense, does it? So that's harder to think about, but that's the difference between multiplying and adding. And when you're just doing one, you're good. And when you're just doing the other, it's fine. And then you combine them on the same day or in the same kind of worksheet, and you start to mix them up. And that's where practice comes in, and checking your answers. And if your answer's wrong, you ask, and we go back over it. And then you try some more, and then it starts to get straightened out for you in your head. So this was y times y times y. What would y plus y plus y be? 3y. 3 yo-yos. Okay. Okay, so this is review from before. You can do this one on your own. Give it a try. What'd you get?
I got 6x minus 3.
Me too. 6x minus 3. Okay? Other people get that? Same thing? Pretty straightforward. What's different about this one? That is different from all the ones we did yesterday as well. Yeah, it's got an x on the outside as well as the x on the inside. So when we multiply, okay, I get 3x times 2x. And then it's going to be a positive and negative, so minus 3x times 1. You don't have to show that step, but that's what's happening. So what is 3x times 2x? 6x squared. And what's 3x times 1? Just 3x. Thank you very much. Very good. Right? Multiplying by 1 doesn't change anything. So just minus 3x. Is that 9 of something? It's not. Because they're not like terms. X squareds and x's are different. You cannot add them together. If you are going to add them together, they have to be exactly the same. So both x squared or both x or both xy or both a's or whatever. Okay, try the next one. Okay, what do you think? 4x squared plus 20
X
x, right? Because there's an x here. When you multiply the 4x times 5, you've got the x as well. Good. 4x times x, 4x times 5. And that's the new part from today, is just managing the x and recognizing that it's changing the exponents and that kind of thing. Keep going. This one's a bit different because they don't have coefficients, so you gotta like understand what that means and how to take care of that. A times A is A squared. Isn't that the same thing here? A times A? So that's A squared. Good. And then A times negative 2 is minus 2A. Okay, and last one, what's different about this one? It's a trinomial. Multiply through by everything. Yeah, multiply through is what I said. Multiply 2x by everything, yeah. So, and then stop at the end, right? You stop at the end of the bracket. So how do I do the first part? 2 times 5, which is?
5x.
Hold on. 2 times 5 is?
10.
10. And then x times x squared is x to the 3. Not 3x, but x cubed, right? X to the 3. So again, adding the exponents. X to the 1 times x to the 2. 1 plus 2 is 3. Sometimes it's helpful, and you'll see in the solutions, I'll often do that for some of the questions to remind us where those numbers come from, why it is what it is. You could write out that step, not every single time because you're going to get bored of it, but once or twice, so you really remember what it is exactly that you're doing, forcing yourself to remember that you're adding those. Okay, what's the rest of this one? Yep.
Minus 6x
Oops. Minus 6x
squared,
squared, good.
and then plus 18x.
Good. Very good. Okay, and then final two, everybody's got that okay? Final two questions. And when it says expand and simplify, and we have two brackets, we know that in the end we're going to have to collect like terms, so but it's the same kind of idea. Look at this one has an x, and this one doesn't. So, you know, each is going to be just a little bit different. So I want you to try both of those on your own, just the first step, if you're at least if you're comfortable with that. Again, look how I take the 2x and multiply by the two things in the brackets and then stop. And then I take the 5 and multiply by the two things and then stop. And 5 times x is just 5x. It's not 5x squared. It's just 5x. But 2x times 3x is 6x squared. So going back and kind of reviewing all the little things that we've done all the way along in a question like this. Like in this unit at least. So what are my like terms? I've got an x squared. I've got two x terms. And I've got a constant. So if I've color-coded them like that, I can add the x's together, the orange ones, But the other ones are on their own. So 6x squared, 2 plus 5 is 7. And the 10 is just on its own. And then I'm done. Don't mash them together. Don't force them. It's not 23 something. 6 and 7 is 13 plus 10 is 23. No, they're not like terms. Notice how I keep repeating this because it's such a common thing for people to do. Okay, try the next one. Okay, then check your answer at the end. I got 16a squared plus 33a. Look again how I've kind of color-coded things. So in this case, a little bit different from the last question. I got 2a squared terms, so I can group them together. 15 and 1 is 16. And I got 2a terms, 35 minus 2 is 33. So again, I color-coded them to show where things are going. That's just collecting like terms from the first day of the unit. And then there's some distributive property from the second day, and then the exponent laws that we started looking at yesterday. But again, look at how these are nowhere near as complicated as some of the harder ones that we were doing yesterday, where we were focusing on the laws. These end up just a little bit more simple. A times a is a squared. That's sort of the, we don't go a lot more complex than that. The nice thing about these is they are all pretty similar to each other, so the more you practice, the more you get familiar with how they look, and you'll get confident with how they work. Whereas the other questions that we were doing yesterday, you know, there was a lot of different types, so it's a little bit trickier to get really good at it.